Hello everybody, it's me again, Rich Andre, and today I'm going to be teaching you how to solve ideal gas laws stoichiometry problems. Okay? This is going to be encompassing the mole-to-mole relationship, okay, for stoichiometry, and we're going to use the ideal gas law formula along with the mole-to-mole relationship formulas in order to solve these problems, okay? So first we have the first problem. Nitrogen gas reacts with hydrogen gas. Okay, so there's one nitrogen here plus 3 hydrogen is equal to NH3. Okay, so if 5.00 liters of N2 is held at 2.00 atmospheres and 300 Kelvin, sorry about that, Kelvin, how many moles of NH3 can be produced? Okay, so first we have to take note of the ideal gas law formula, which is PV equals nRT, wherein P is the pressure, V is the volume, N is moles, R is the ideal gas constant, and T is temperature in Kelvin. Okay, so we're going to be using that and the variations of it. So the first problem here, let's first list down the givens. Let me just list down the givens. We have 5.00 liters. So the volume is 5.00 liters. The pressure is 2.0 atmospheres. And the temperature is 300 Kelvin. Now we're trying to find the moles of NH3 that can be produced. Okay? So the first thing that we need to do is we need to convert the volume. Okay? We need to convert the liters to moles first. The liters of N2 is 5.00 liters. So in order for us to get the moles of N2, we need to use this formula. This is the mole formula. See? M stands for mass. And NW stands for molecular weight, which is the molecular weight of the chemical compound involved, or the element that is involved. So we have mass. So we have 5.00 liters for N2 over the molecular weight of N2. So we can search up what the molecular weight of N2 is. So the molecular weight of N2 is 28.0134. If we divide that 5.00 divided by 28.0134, we'll have this answer, we can round that up to 4 decimal places. So that the answer will be 0.1785. Okay. So now that we've got the moles, we need to times this by the molar ratio of what we're trying to find. See? We're trying to find NH3. So the molar ratio consists of the coefficients in the equation here. This is 1, and 3, and 2. So we're trying to find NH3. What is the molar ratio between NH3 and N2? There's going to be 1 N2 per 2 NH3s. So we have here 2 NH3 divided by 1 and 2. 2 divided by 1 is 2. So 2 times 0.01785 is 0.357. Now we have the moles for NH3. This is the moles of NH3. Now we're going to convert this to what we're trying to find, which is how many moles. Okay. Now that we have this, we have to use the formula, the ideal gas law formula again. So if we have PV equals nRT, actually, let me just remove this. This is not the moles, okay? Sorry about that. So we have PV equals nRT. What we're trying to find is the moles. So N equals PV over RT. Okay? So substituting the numbers, we have the pressure, which is 2.0 atmospheres, times the ideal gas constant. By the way, the ideal gas constant can also be rounded up to 0.0821, but we're just going to use this. Okay. So what is the temperature? Temperature is 300 Kelvin. Over RC. Oh, sorry about that. You actually put this here on the bottom. Times the temperature. Temperature is here. The volume is 5.00 liters. Okay. Let me see if I'm doing this right. Okay. Let me just see if I'm doing this right. 0 times 5 point. I may be wrong on this, but I'm trying to be optimistic. divided by 0.08205. Yep. 0.08205 times the 300 Kelvin. It's about 0.4062. So we're wrong on that. Okay. Let me just see where I went wrong here. It's the molar ratio 0.174. This is going to be a moles, I believe. Zero 18785 0.8. We just see the answer. Okay, the answer sheet is going to be 0.812 moles, which is far from this. So we must have done something wrong. Okay. But I'm going to see where I went wrong here. So this is going to be the moles of the NH3. So I believe after you've gotten this, you have to times it by 2. So we have to times that by 2, I believe. Let me just see if that's right. Times 2, which is 8.12 moles. 0.812 moles, okay? So about 0.812 moles of NH3. So 0.406 times 2, because there are two NH3s there in the equation. 0.406 times 2 is equal to 0.812. Okay? 0.812 moles of NH3. By the way, the only reason why ChatGPT's answer doesn't coincide with here is because he presumably took the rounded up version of this equation and then times it by 2. So it's not actually 0.813 in this context. But other than that, it surely would be 0.813 if we're calculating linearly in this manner. Okay, so let's try the second problem, and we'll stop on that. We can stop on the second problem. Okay. So oxygen reacts with hydrogen. You have 2 hydrogens here plus 1 oxygen is equal to 2 water atoms. If 3.50 liters of syrup, let me just delete this. The 3.50 liters of oxygen is at 1.50 atmosphere and 298 Kelvin, how many moles, try to find the moles again, of water can theoretically form? So given you have volume is equal to 3.50 liters of oxygen. Pressure is equal to 1.50 atmospheres. Temperature is at 298 Kelvin. We're trying to find N of H2O. NH2O. Okay? So let's use the ideal gas law formula. So PV over RT, pressure 1.50 atmospheres, times volume is 3.50 liters over the ideal gas constant, which is 0.08205 times temperature, which is 298 Kelvin. So canceling everything, okay, we get only the mole unit. And if we substitute everything here, you have 1.50 times 3.50 here over 0.0 the gas constant and 298 Kelvin. We get 0.2147 times the molar ratio. Okay, so we're trying to find H2O. So how many H2Os are here? 2 H2O, and then one O2. So times this by 2. So 2147 times 2. 0.4294 is equal to 0.4294. And then we're going to use the answer. Okay, 0.4294 and times it by the coefficient here. Wait, hold off on that thought. I may be wrong on that, but let's see. Okay. Don't times it by 2 before I say so. Check. So that is about 0.4294 moles. But since there are two here, there are two hydrogens, you have to times that by 2. Okay, times 2. Which is equal to 0.8588 moles of hydrogen. Okay, that's going to be our final answer. Let's check the answer sheet. It says here 0.214 moles. Why is that? 214 moles. Let me just check. I'm just trying to fact check ChatGPT here. How did you solve the question here? So, okay. So he solved it by getting this. So we don't need a mole ratio. Is that it? Okay. Sorry guys. I made a big mistake here. You actually don't need a mole ratio here. You don't need to do all that, according to ChatGPT. But otherwise, our answer would be correct. The answer would be 0.214702. When it comes to NO2. Hold on. Oh, so ChatGPT is the one in the wrong. Oh my goodness, so it's ChatGPT that's the one in the wrong, not me. 0.429? Okay, so I did an extra step here. 0.8588. Yeah, I did an extra. You don't need to times it by 2, apparently. But let me just fact check again. Okay. So this is actually going to be the final answer. Hopefully ChatGPT is right. Otherwise, I would be kidding myself, because ChatGPT always makes mistakes when it comes to math. But either way, I believe that's going to be the final answer. You can see why ChatGPT made a mistake here, but either way, that's going to be the final answer. We did a lot of going back and forth, and then I realized that ChatGPT doesn't actually know the final answer. That's actually kind of sad. But I don't know why his answer, ChatGPT's answer, was different here. I had to times the moles that I got by 2 because there's a coefficient 2 here, and the answer that ChatGPT gave me was right. So in this case, times multiplying it by 2 would also be right, but apparently it's not. So let me just confirm. Okay, so I was the one in I was the one with the problem there. I actually times it by 2 because I assumed that you had to do something like you had to do something with the coefficients of the elements, but apparently it was not. Okay, the chemical compounds. That was where the confusion came from. So the mole ratio is where the times 2 came from, and that's about it. So thank you guys for watching. If you like this video, please give me a thumbs up and subscribe to learn anything. But if for perchance you have like a criticism, or if you were confused, which understandably you probably are, okay, please give me your honest feedback in the comment section. Thank you guys for watching. I'll see you guys in another video.